So welcome again to this segment as we continue with our quick revisions in physics. So there the question was saying that the figure below shows a circuit consisting of a 12-volt battery with a combination of resistors between pointer X, Y, and Z. So you can see X, Y, and Z. So that's a combination of resistors. So if you look at the 6 ohms resistor and the 12 ohms resistor, these are branching, so they are simply connected in parallel, as opposed to this resistor, the two resistors. This resistor is connected in series as opposed to these two, which are connected in parallel. Now, of course, the question says that calculate the effective resistance. So they want you to find the effective resistance. Now, when they use the word effective resistance, they can also use the word equivalent. So they can also use the word equivalent resistance, or they can use combined resistance. Like I said, effective resistance. Whenever they use such words, it simply means they want you to find the total resistor between the points that they have actually told you. So for example, it says calculate the effective resistance between Y and Z in the circuit. So they just want between Y and Z in the circuit. That's all. So how do we get the effective resistance between Y and Z? So put up the solution in this direction. It's very simple. If you have got two resistors that are arranged in parallel, then the total resistor R total is equal to, let's take for example, this is R1, and let me call this one R2, and let me call this one as being R3. So if you are just finding, remember it's between Y and Z, so meaning between these two parallel resistors, you can use the inventing rule, which says you just multiply the two resistors in parallel, R1 multiplied by R2, then you divide by the sum of R1 plus R2. That's what we mean. So therefore R1 is 6 times my R2 is simply 12 divided by 6 plus 12. That's what we mean. So R total, if you multiply, in this case, if you multiply 6 times 12, that should be 72, but let's just counter check that. Yes, that is actually going to give us a 72. So it will be 72 over 6 plus 12 is going to give us 18. Now, meaning that the resistor total there will be 72 divided by 18, and that is going to give me 4 ohms. Let me just write the symbol there, 4 ohms in this case. So that is the resistance between Y and Z. So that's the total resistance between Y and Z that they wanted us to find. Now what you have just done here, it's like you have simplified the diagram. It's like you have simplified the diagram. Now let me show you how the diagram can be simplified, because we have found the combination of the two resistors. So we have the 2 ohms resistor. Now that you have found the combination of the two resistors in parallel, they can now be represented by one resistor, and I've changed the color. I'm now using black. So this will be represented by 4 ohms resistor. That's what you have. So this circuit can now be simplified by that, because we have found the combination of these resistors that are in parallel there. So that's what you can do. So in simple terms, we are talking about this one. Now remember, here they have given us is a 12 volt. For resistors that are in series like that, the potential difference is actually divided, but the current is going to be the same. And that's why the question says find the current through the 2 ohms resistor. So what will be the current that now will pass through the 2 ohms resistor? Let me just write here the effective resistor between Y and Z is actually 4 ohms. We'll come back to that, so that I can actually just clean up this section and try to answer again. So now the current through the 2 ohms resistor, because this resistor is in series, it simply means the total current passing through the whole circuit will be equal to the current passing through the 2 ohms resistor. So what we are going to do, we need to find now the total resistance in the whole circuit. So what is the total resistance in the whole circuit? it will be the resistor in series plus that resistor that was in parallel. So I'm saying resistor series and resistor parallel. So the resistor in series was a 2 plus the resistor in parallel, which we found to be 4. So that is going to give you a 6 ohms, meaning that this is the total resistance in the whole circuit. Now, because the B part there says that we find the current through the 2 ohms resistor, and the current through the 2 ohms resistor is the same as the total current. So we can apply Ohm's law that tells us. So remember, according to Ohm's law, if you want, you can put it in a triangle there. Voltage is equal to current times resistor, but we want to find the current. So current will be equal to voltage divided by the resistance. So the current total will be equal to the voltage total divided by the resistor total. So what is the total voltage they gave us in the whole circuit? It is 12 volts divided by the total resistance, which is 6 ohms. So the current total will be equal to 2 amps. That's what we mean. Therefore, current through the 2 ohms resistor in this case, so I can simply say that current, I can simply say current in the 2 ohms resistor is simply 2 amps. That's what we mean. So that is basically the current that is going to pass through the 2 ohms resistor. So that's the way you needed to calculate it. So first of all, you find the total resistance by adding this plus the combination of that gives you that. Then you can apply Ohm's law to work out the current passing through the 2 ohms resistor. That's what we mean. And of course, when you calculate that, the other question, part C, there now says calculate the voltage across the 2 ohms resistor. So therefore, calculating the voltage across the 2 ohms resistor becomes even simple, because according to Ohm's law, voltage is equal to current times resistor. So the voltage, what's the current passing through that one? It is simply 2 amps multiplied by the value of that resistor R3, which in this case is 2 ohms. So the voltage will be 2 times 2. That is going to give us 4 volt. Remember, the unit for voltage is the volt, and that's what you needed to calculate in this question. Now, of course, just a few series of combination that I can give you just to remind you of a few things that you need to know under current electricity, especially when it comes to resistor combination. You can have resistors that are in series, or you can have resistors that are in parallel. So remember that if the resistors are arranged in series like that, if you have got resistors in series and the combination is that, this is what you're having there, then it is very simple for resistors. If that is R1, R2, and that is R3, for resistors that are in series, you need to remember that for resistors that are in series 1, the current, so remember that the current is the same. So the current will be the same as the total current that will pass through. So if you were to connect an ammeter here, it simply means the current that will pass through this will be the same as that, and it will be the same as that. And that's the concept that you need to remember. Then we can simply say that for resistors in series, they are potential difference, PD dividers. They divide the potential difference between them. So meaning the potential difference across R1 and the potential difference across R2 and R3 may vary depending on the values of the resistor. But remember, the resistor total, you just need to add them, R1 plus R2 plus R3. So that's the way we get the resistor total, if at all it is simply in a series combination. So these are important. The current is the same, but they are potential difference dividers. Those are things that you need to remember. So meaning, if I was to connect an ammeter somewhere here, the ammeter reading that I'm going to get for voltage 1 may be different from voltage across R2, and my voltage will be different across R3. Now, because the potential difference is divided, it simply means that the voltage from the source will be a combination of the voltage passing across resistor 1 V1 plus V2 plus V3. That's what we mean when it comes to that. So you need to remember and understand such concepts that are there. Let me give you a quick example right on what we are using. Let me say that resistor 1 in this case is actually, let's say that is the total voltage is 12 volts. Then let me say that is 2 ohms. Let me say that is 3 ohms, and let me say that okay, let me say that that is actually 1 ohms. That's what we mean. So what would be the total what would be the total resistance or the effective resistance in the circuit? You just need to add R1 plus R2 plus R3. So in this case it will be 2 plus 3 plus 1, and that is going to give me 6 ohms. That's what we mean. So that is the total resistance in the circuit. Suppose the question was asking you to find what is the total current in the circuit. How do we do that? Well, the total current, it simply means that according to Ohm's law, current is equal to voltage over resistor. So the total current will be the voltage total divided by the resistor total. So the total voltage there that I have is simply 12 volts divided by the R total, which we just found, which is 6 ohms, and hence that will give you 2 amps. So now, like I said, the current is always the same, meaning the current passing here is 2, the current passing there is still 2, and the current passing there is 2. Now, therefore, let's find the voltage. Let's find the voltage across, let me say, across each resistor. Suppose you are told to find the voltage across each resistor, then how are you going to go about it? Well, to find the voltage across each resistor that you have there, the voltage across each resistor there, it simply means that you are going to say, okay, fine, voltage 1 across will be the current times the value of resistor 1. The current is 2 times the value of resistor 1 is a 2, and that will give you 4 volts. What would be the voltage across resistor 2? It will be the current times resistor 2. So which is going to be, the current is 2, the value of that resistor 2 is 3, and that will give you 6 volts. The voltage across resistor 3 will be the current times the value for resistor 3, which will be 2 times 1, which will give you 2 volts. Now, if you add all this, you add V1 plus V2 plus V3, remember what we said there, if you add 4 plus 6 plus that, it will give you a total of 12 volts. No wonder we say they are potential dividers, and that is what you need to remember, when it comes, to resistors that are found in what? That are found in series. All right, I hope you are picking up that. It's very important. We are doing a quick revision so that you are able to see. Let's quickly go to what we are calling as being resistors in parallel. So if you have got resistors that are found in parallel, it simply means, for example, you can have 2 resistors that are found in parallel. Don't waste time. If the resistors that you have are simply in, there are only 2 that are in parallel, then you don't need to waste a lot of time. Picking up some examination questions as my examples that I'm having. Suppose this is 3 ohms, and I tell you that this is 6 ohms, and I tell you that is 12 volts. Then they tell you to say, find the equivalent resistance. So if they tell you to find the equivalent resistance, they mean you find the total resistance in that circuit. Of course, you can use in layman's language, what we are calling as being 1 over resistor total is equal to 1 over resistor 1 plus 1 over resistor 2, because there are only 2 resistors. In this case, I mean, if I told this one is R1, and let me call this one R2, by the way, that is a 6 ohms resistor. So it simply means that it would have been 1 over R total be equal to 1 over resistor 1, which is 3, plus 1 over resistor 2, which is 6. So it would have been R total is equal to, you find the common denominator where 3 and 6 can go into, the lowest, which is 6. Then 3 into 6 is simply 2. 2 times 1 on top will be 2 plus. Then 6 into 6 is 1. 1 times the 1 on top will give you 1. So it will be 1 over R total will be equal to 3 over 6. Now what you can do here, you can simply invert them. That's what we mean. In other words, change them upside down. That's what I mean. That's what I mean inverting. So when I invert this, it means that I will have RT over 1, and the 6 goes on top, the 3 comes down. That's what I mean. In other words, 1 into R total, it will still give you R total. So when you eliminate that one, you just say R total, you change this, the 6 goes up, the 3 comes down. So R total will be equal to 2 ohms. That's the way you can find it. Now this is layman's. Normally we apply this formula here. We apply this formula here when you have got 3 or more resistors that are in parallel. But if you have only 2 resistors that are in parallel, don't waste time. So what would have just done, like I said, R total, you just multiply the product of the 2 resistors, R1 times R2, then you divide by the sum of R1 plus R2. So meaning R total will be equal to, it would have been 3 times 6 over 3 plus 6. So that would have been 3 times 6 is actually 18. 18 divided by 9. What is 18 divided by 9? That is simply going to give you 2 ohms there. That would be our R total. So you can see this value and that value that we got. This one is much shorter as compared to this one that we have. So if you have got 2 resistors, this is only applicable for 2 resistors that are in parallel. But if you have got 3, then you need to stick to the formula that we have actually shown you here. You can keep on adding depending on the number of resistors. Okay, so let me show you a kind of combination again that you are going to find in the exam. Suppose they give you something that looks like this, and they tell you to say, okay, fine, they want you to find the total resistance. Look at this one. They give you this and they tell you to say, they give you this is 2, and they tell you this is actually 4 ohms, 2 ohms, and they give you, or let me start with 1 ohms, and they tell you to find the total resistance. How do you find that? Well, you don't need to struggle with that. Remember, these 2 resistors are like arranged in series. So we can actually break down this. We can resistors in series, you just add them. So 2 plus 1 will give me 3. So I'm going to have that. Then this side, I'm going to have 6 ohms there. That's what we mean there. So now when you have this, it is easy for you to find the total resistance. How? Resistor total, you just get the product 3 times 6 over 3 plus 6, and then R total will be equal to 18 over 9, and that will give us 2 ohms. So that's basically the way you can go about it. These are exam questions. Another type that you may find quickly, they may also try to tell you something that looks like this. They may give you something that looks like this, and they may tell you to find the effective resistance. You don't need to worry about that. Suppose I tell you that that is actually 1 ohms, and I simply tell you to say that is 5 ohms, and I tell you to say that is 2 ohms, and I tell you that is 4 ohms. You don't need to worry again when they tell you to say, find the effective. They tell you to find the effective resistance. Again, you can reduce this circuit because these are in series and also these are in series. So you can reduce it like this, and hence you can find the total resistance. So 1 plus 5 will give you 6, and 2 plus 4 will give you again 6. You have seen how we have reduced it. So from here now we can find the resistor total. How? We just need to multiply 6 times 6 divided by 6 plus 6. So R total will be equal to 6 times 6 is 36 over 6 plus 6 is simply 12, and hence our total there is going to be equal to 3 ohms resistor. So you see, you don't need to struggle, and that's the key that you need to remember. If you're able to find the effective resistance in a circuit, then well and good. Let's put up a last one that you can basically enjoy, where you have got a resistor in series and you have got another one found in parallel, and they tell you to say, find the effective resistance. Let's say that is a 3 ohms. Let me say this is basically a 4 ohms, and let me say that that is basically a 6 ohms, and they tell you to find the total resistance. You don't need to worry. The resistor total B is the resistors in series plus those resistors that are in parallel. So when I look at this combination here, it is actually parallel arrangement, and this resistor here is actually series arrangement. So therefore it will be R total is equal to the resistor in series plus, how do you get the resistor in parallel? Like I said, if at all we can name them, I simply say this is R1, R2, and that is R3. It simply means that it will be R1. Then for me to get this combination there, you just need to multiply R2 times R3 divided by R2, in this case, plus R3. So that's the way you can actually go about it. So how is that going to be? So how can we actually work out that? Well, it would be R total will be equal to, my R total is going to be, my R1 is 3 plus, here it will be 4 multiplied by 6 over 4 plus 6. I hope you are getting me. So that is 3 plus 4 times 6 will give you 24 over 4 plus that will give us a 10 there. So therefore it is going to be 3 plus 10 there will give me 2.4. So when you add the 2, that will give us 5.4 ohms, and that's the way you simply get the total combination or the total resistance in the circuit there when you have series and also parallel. Watch out for more videos. I'll give you more concept on other topics that can help you to quickly revise and answer such questions. Thank you so much for watching. You can please subscribe to my channel in case you need to learn in other subjects like physics, chemistry, biology, and mathematics. Even additional mathematics for those of you that are doing pure science, you can still watch out for my series and actually get to learn something. Knowledge is power.